Imagine a huge set, like a billion registered usernames. If you need to check whether a new name already exists, storing every name exactly can consume enormous memory. A Bloom filter offers a space-efficient approximate way to answer that question. At the core of a Bloom filter is a bit array made only of zeros and ones. Here we use 12 bits for the demo. At the beginning, every bit is 0. A hash function maps an arbitrary input to a number within a fixed range, which becomes a position in the array. A Bloom filter does not rely on one hash function alone. It uses several different ones at the same time. Here we use 3, H1, H2, and H3. The same element usually lands on different positions after passing through different hash functions. When inserting an element, the Bloom filter uses multiple hash functions to map it to several positions in the array. Then, it sets all of those corresponding bits to 1. Now, insert another element, banana, and again use the 3 hash functions to find its positions. Notice that bit 5 overlaps with apple. Setting a bit to 1 again causes no problem. Now query whether apple is in the set. Again, we compute its 3 hash positions and check whether all those bits are 1. Because apple was actually inserted, all 3 bits are 1. The filter answers, possibly present. Query cherry, an element that has never been inserted. As soon as any one of its hashed positions is 0, we know with certainty that cherry is not in the set. That is one of the key guarantees of a Bloom filter. No false negatives. But a Bloom filter is not perfect. Now query durian. It was never inserted either, but its 3 hash positions happen to have already been set to 1 by apple and banana. So the filter incorrectly concludes that durian may exist. That is the trade-off of a Bloom filter: false positives. A Bloom filter uses very little memory to provide approximate membership tests. It guarantees no false negatives, but it does allow a certain probability of false positives. That trade-off between space and accuracy is exactly why Bloom filters are so widely used in caches, databases, and network systems.